Good morning students. In this class I am going to discuss about welding process. What is welding? Welding is the process of joining similar or dissimilar metals by the application of heat. Welding can be done with or without application of pressure and with or without the addition of filler metal. While welding, the edges of the metal pieces are either melted or brought to plastic condition. The filler material has a similar composition and melting point as the base metal. The filler rod is used to make up losses during welding process to fill up any gap between the joint surfaces and to produce a fillet. Welding is used for a permanent joint. Applications. Welding is used for permanent joints as we discussed already. It is used in the manufacture of automobile bodies, aircraft frames, railway wagons, machine frames, structural works, tanks, furniture, boilers, general repair work, and shipbuilding. The welding process can be classified two main types. One is plastic or pressure welding and another one is fusion or non-pressure welding. What is plastic or pressure welding? In the welding process, the metal pieces are heated to a plastic state. They are pressed together to make the joint. Since the pressure is applied, the plastic welding is also known as pressure welding. Examples for plastic or pressure weldings are spot welding, projection welding, and seam welding. Next, fusion or non-pressure welding. In fusion welding, the metal at the joint is heated to molten state. Then it is allowed to solidify. Pressure is not applied in this welding process, so it is known as non-pressure welding. Examples: gas welding and electric arc welding. The figure shows that types of welding process. The welding is basically classified into two main types. One is solid state welding and another is fusion welding. The fusion welding once again classified into three types. One is autogeneous welding, homogeneous welding, heterogeneous welding. Autogeneous welding means there is no filler material is used for joining the two materials. Where homogeneous welding is filler material is used, but the filler material is composition of same with the base material. Heterogeneous welding means here also the filler material is used, but the composition is different from the base material. Classification of welding process. The welding process are classified as following: gas welding, arc welding, resistance welding, solid state welding, thermochemical welding, and low temperature welding. So the figure shows that welding related process and allied process. So as already we come across the types of welding process, and the allied process are somewhat related to the welding process as metal depositing process, soldering, brazing, adhesive bonding, and metal spraying. Next one is gas welding. What is gas welding? Gas welding is the process of joining two metal pieces by a gas flame obtained by the combustion of fuel gas and oxygen. It comes under a fusion or non-pressure welding process. In this process, a gas flame is used to melt the edges of the metal parts to be joined and allowing it to solidify, thus forming a required joint. A filler material of similar composition and melting temperature may also be used to fill the gap between the parts to be welded. There are different combinations of gases used to obtain the hot flame. Example, oxygen and acetylene, oxygen and hydrogen, air and acetylene, oxygen and propane. The combination of the oxygen and acetylene is mostly commonly used as the heat produced is maximum in this case. So that's why we prefer oxyacetylene gas welding. Then next we are going to discuss about gas welding technique. In gas welding, the position of weld, the tilt of the torch, the filler rod, and the direction of flame play an important role in determining the quality and speed of the weld. Generally, we used two welding techniques are leftward or forward welding, rightward or backward welding. Leftward or forward welding means this technique the weld is started from the right hand of the seam to the left hand. This method is employed for welding plates up to 3 mm thickness without edge preparation and up to 5 mm thickness with edge preparation. The plates above 6 mm thickness are not economical to weld with this type of technique. Next, rightward or backward welding. This method is employed for welding plates more than 5 mm thickness. In the plates up to 8 mm thickness, edge preparation is not required, but beyond 8 mm thickness plates should be beveled to about 30 degree. This method is economical for heavy steel sections over 12 mm thick because of less gas consumption and reduced welding time. Thank you.